Energy Lock, the double lock insulated building wall system, provides outstanding benefits in energy efficiency, sound abatement, strength, and stability. It's also resistant to air, water, dry rot, mildew, insects, rodents, even fire. Ease of installation is another major benefit. With a minimal amount of pre-planning and preparation, the actual installation of the blocks is amazingly simple and straightforward. The Energy Lock building system is based on a polyurethane block which measures 8 inches wide by 8 inches high by 32 inches long. The locking system is a tongue and groove type that interlocks each block precisely on up to 4 sides to form a rigid system of components. From this basic block, alterations are easily made to accomplish all construction requirements, as well as to accommodate any design elements in the building plan. Required tools include a keyhole or handsaw, a builder's square, a 5-inch circular hole saw, a retractable razor knife, a tape measure, a builder's level or transit, a large miter box for sizing block and cutting angles, and a roll of string or dry line. As you prepare for construction, the first step is to make sure your exterior wall dimensions are based on 8-inch increments to accommodate the block size. Generally, no other alterations to the plans should be necessary. Before we continue, there is one important point to be made. While the Energy Lock system will meet all building codes, engineering specifications and local building codes may vary concerning the amount and placement of steel and concrete. So always check your plans and local codes for any variations to the general procedures presented here. The Energy Lock building wall system can be constructed using either a footings or slab-on-grade foundation. If the slab-on-grade type is planned, carefully level and place L rebar according to code, as you would for other block-type construction. Then, as you start to build, anchor the first course to the dried concrete with an adhesive. For a foundation using footings, there is a very efficient method of building. First, the footings can be dug or formed and should be as level as possible. But before any concrete is poured, prepare to outline the exterior dimensions of the building using string either tied to nails that are attached to the forms or tied to stakes carefully secured in the grade. This step is very important because you will use this string as a reference to place the block in a straight line. The footings can now be poured in compliance with local building codes. As soon as the footings have been poured, attach the reference string and use it as a placement guide as you begin laying the Energy Lock blocks on the wet concrete. Place the blocks end to end, taking care to keep the area between each block free of concrete. Then, on the first course, insert a 16-penny nail to hold the blocks together. At the same time, stagger the seam and begin placing the second course. This provides a quick test of how the blocks are fitting and will help serve as a method of leveling all the blocks together. At this point, it is not necessary to be too concerned about the vertical leveling. But as you progress, continue to compare your work to the reference string for possible adjustments. Right-angle corners are accomplished by making simple modifications to the basic block. First, size the corner block to fit lengthwise using a miter box and handsaw. This should be done in 8-inch increments. If the full 32-inch block is used, then remove only the male tab on the end. Next, using a retractable razor knife, cut and pinch out the top interlocking tabs on what will become the corner cell. Then position this modified block. Now remove the male tab on another block and carefully place it at a right angle to make the corner. For the moment, this seam is held together only by placement of a 16-penny nail. Next, follow the same block modification procedures to build the corner on the second course, with one important difference. This time, make certain that the second course overlaps the open corner seam. This overlapping with the top block produces a solid interlock between the two lower blocks. By carefully following and repeating this interlocking process, the corners will be completely solid and will also serve to brace and balance the wall. If your plans call for a 45-degree angle or bay windows, carefully cut the angles using a miter box. Then, place and secure the blocks with 16-penny nails at each seam. But because there will be no interlocking system at these angles, before you pour concrete, brace these seams on the exterior and interior to provide support. This is only necessary when there is no interlock. As the first two courses are completed, the next step is to add 36-inch L rebar to each cell, pushing it down about 5 inches into the still wet concrete footing. At this point, you are ready to begin the leveling process. This is done by shooting the grade at each block with a builder's level or transit. If the block is high, just lean on both courses until you reach the desired height. If the block is low, you must raise both courses until they are level. In some cases, you may need to add some concrete under the block. Generally, if you take some care in forming the footings, you will only be dealing with a plus or minus of a half an inch as you level the walls. Before we continue, let's review the steps taken up to this point. First, make sure your exterior wall dimensions are in increments of 8 inches to accommodate the size of the block. Then, form or dig footings and prepare for a guide string to be easily put in place, showing the outside dimensions of the walls. Pour the footings, then position the guide string for a reference. Start laying the Energy Lock block 2 courses at a time on the wet concrete. Next, insert 36-inch L rebar through the appropriate cells into the footing concrete. Then level the first 2 courses using a builder's level or transit. It is recommended that walls be built, then poured in 4-foot levels or lifts, although higher lifts can be made. So continue by adding courses of block up to the 4-foot level. The Energy Lock building system gains its incredible strength from the use of a concrete and steel grid within the wall structure. Vertical cells of the wall are filled with concrete and rebar at specified intervals, forming posts. And these posts are bonded together horizontally with concrete and rebar to form beams, also at specified intervals. Depending on engineering and local building codes, the height generally specified to add a bond beam is every 4 feet. However, if the wall is below grade, then a bond beam should be included every 2 feet. Bond beams require a simple modification of the block to allow a 5 by 5 inch continuous horizontal concrete flow that is reinforced with steel. These modified blocks are available from Energy Lock. However, if necessary, it is possible to create bond beam blocks right on site. First, cut the block lengthwise along both sides of the open cells. Cut down 5 inches from the top. Then, using a retractable razor knife, cut and remove the 5 by 5 inch sections to create what is basically a trough. Use the modified block to build the entire bond beam course. But to maintain a continuous flow at the corners, you'll need to alter the corner cell by cutting a 5-inch square from the side instead of the end. Also, to hold the concrete in a horizontal flow, build the bond beam using 6-inch grout stop, available from your local builder's supply. Don't forget to open up the covering on cells that are also part of the filled vertical columns. Bond beams require either 1 or 2 pieces of steel rebar reinforcement. Building codes generally state that the ends must be overlapped by at least 40 times the diameter of the rebar being used. The rebar can be tied in the traditional manner, or if local code allows, you may use a rebar chair available from Energy Lock. The rebar chair rests on top of the bond beam block and is designed to make sure the rebar is efficiently and correctly placed in the middle of the poured beam. When the bond beam steel has been properly positioned, add another course of block. This will provide support to the bond beam block. Now we are ready to pour the first 4-foot lift of wall. In most cases, you will wish to use a grout pump to provide control of the concrete flowing into the 5 by 5 inch openings. And before you start, assemble a fixed or rolling type scaffolding which will allow you to easily reach and direct the concrete into the cells. When pouring the walls, you may find it is easier to make 2 complete passes, filling each specified opening about halfway, then circling back to top them all off. Depending on the building code or engineering specifications, you could be required to place and tie vertical rebar prior to pouring concrete. Otherwise, at the completion of the pour, insert 6-foot rebar into each filled vertical cell. Remember, the ends must overlap in compliance with local building codes. Once the steel is in place, check for square and, if necessary, use 2x4s to plumb walls until the concrete has set. While one can compensate for minor deviations, understand that any departure from square and perfectly straight at a low level will be exaggerated as you go up the wall. After you have completed the lower 4-foot pour, you can start to lay more block. There is no need to let the concrete cure completely, as long as you're not climbing on or pushing against the wall. As you complete the next 4-foot lift and reach the 8-foot or load-bearing bond beam, there are additional steps that must be taken. In order to tie ledgers and other framing into the Energy-Lock wall system, J-bolts are added to the bond beam. To do this, at each cell where a J-bolt will be required, use a 5-inch circular saw to cut holes in the side of the bond beam blocks. Next, cover each hole with reusable metal or masonite plates available from Energy-Lock and secure them with 4 fasteners. The plate will serve to stop the flow of concrete at the outside surface of the block. The center hole will be used to insert a J-bolt into the wet concrete. Now place rebar inside the modified blocks as before, but note that load-bearing bond beams require the placement of 2 horizontal pieces of rebar instead of 1. Pour the concrete as before. Then push the J-bolts through the holes in the plates and into the wet concrete. Next, add the vertical steel in each poured cell, and then square and plumb the walls. After the concrete has cured, the cover plates can be removed and reused. The J-bolts remain to secure conventional building materials to the wall. Okay, let's review again. Although higher ones are possible, it is recommended that walls be built in 4-foot lifts. A horizontal bond beam is used to tie the vertical concrete and steel together into a grid. To do this, use modified bond beam blocks that will accommodate a continuous horizontal flow of concrete, and place at least 1 piece of rebar inside the trough. Generally, engineering and building codes will require bond beams at 2-foot intervals for walls below grade and 4-foot intervals for all others. Pour concrete into all specified vertical cells and bond beams. Making 2 passes simplifies this pouring process. Add rebar to all the filled vertical cells. Remember to overlap the ends. Then square and plumb the walls while the concrete sets. Also, add J-bolts in the bond beam to provide anchors for any standard construction to follow. So, now you know the basic techniques used with the Energy-Lock insulated building wall system. Specific items in the building plan, such as doors, windows, or multiple floors, basically call for variations in the amount or location of concrete and steel. Remember, engineering specifications and building codes may vary, so always check your plans and local codes for exceptions to the general procedures presented here. Starting with the general construction standards for multiple floors, walls below grade must have every vertical cell filled with concrete and rebar. In walls above grade, if there is only 1 level, the general requirement is to fill every 3rd cell. But if the plans call for 2 stories above grade, every other cell would normally be filled on the 1st floor and every 3rd cell filled on the upper level. Also, for all corners above grade, you must fill the corner cell plus 1 cell on each side. In addition, the vertical concrete and steel must be tied to a horizontal bond beam every 2 feet in walls below grade, or every 4 feet in walls above. And every bond beam course requires 1 piece of rebar, with the exception of load-bearing bond beams which require 2. Load-bearing bond beams occur where any floor or ceiling joists will be tied to the walls. To attach these joists, Include J-bolts in the double reinforced bond beam at 16-inch intervals or to code. When you are ready to secure the floor, a ledger plate can be anchored to the J-bolts, allowing you to then attach joist hangers and continue construction as usual. Also, place J-bolts on 32-inch centers in the other walls to tie in the joists and provide additional support. This same configuration of double reinforced bond beam with J-bolts is used to anchor all standard framing, bearing ledgers, and brick ledgers to the Energy-Lock system. To finish off the top of the walls, overfill the bond beam with concrete and strike the excess. Then set J-bolts vertically into the top. When the concrete is cured, bolt on a pressure-treated top plate and continue to build the roof using standard materials and methods. So, to review general construction standards, walls below grade have every vertical cell filled with concrete and steel. Above grade, if there is only one level, then fill